In part one of this video, we discussed the lettering system of the blood types, and I drew some very quick types of cells that represented the 4 different blood groups. I'm going to do something very similar because we're going to talk about now the positive and negative aspect of the blood type. I'm not going to review everything. You can go back into the other video if you wish, but these would make sense to you if you watch that. So here you have some various blood types, and we have the A, the B, the AB, and the O. So what we'll now add is a second gene. So it's a second gene that controls positive or negative. And this gene is completely Mendelian. So you go back and kind of review what it means to be Mendelian, is that there are 2 variations of alleles. There's a dominant and a recessive. So don't lose the fact that these things exist. Just because we're doing exceptions doesn't mean that regular genes or not the actual typical Mendelian, they're still around. So the dominant and recessive, because look at, there's positive and negative, that's all there is. That's very typical of a Mendelian trait. So what you have to know is that having positive blood is the dominant variation, and having negative blood is the recessive variation. But what is hard about this for students is the fact that they forget they have to just come up with a key. And symbols don't often designate dominant recessiveness, so you can use whatever letter you wish. Many times they might use R, because the idea of positive and negative actually revolves around this idea that it was discovered within this variation of a monkey called the rhesus monkey. And so they kind of use it's called the RH factor, R-H-E-S-U-S. So it is the RH factor, so that's kind of why R's are sometimes used, but you can use whatever letter you wish. And what it means to have positive blood means that there is just another antigen, and that was all discussed in the last video. So there is an antigen that is present. A second gene controls another formation of an antigen. So if I wanted to turn this from an O to an O positive, then we can use another shape. So that is an addition of another antigen. Negative is the absence of that antigen. So therefore, O negative technically would be no changes whatsoever. So if I want to transition this to a B negative, I would change nothing about the antigen configuration. But what is different is the fact that if you have antigens, then you also want to have antibodies that fight foreign antigens. So if this is something like B negative, they do not have a positive antigen on there. So therefore, if something that has positive blood tried to enter into that quadrant, they have to have, once again, an antibody. So the antibodies are going to fight the foreign antigen. So think about who can donate to who when it comes to positive and negative. If you have negative blood, you have a stronger immune response. So that means it's going to be harder to enter that quadrant. If you have the antigen, that means you'll recognize it. So negative blood, there's no changes. They can enter. There is no immune system response to something. If we're just talking positive or negative, I'm not talking about letters right here, because obviously B negative would not be able to go over to O positive. But if you just do a side-by-side comparison, there's my O positive, and my O negative would mean that there is nothing around the outside. So that means that it has the A antibody, it has the B antibody, and now it has the positive antibody. So this thing, going from O positive to O negative, is bad news, because the antibody that will fight the foreign antigen will attack. Going from O negative to O positive is fine. All right? So that's just something to think about, because it is a continuation of your understanding of antibody antigen. But it is a second gene. So if you do both of these at the same time, if I'm looking at the inheritance of blood typing that includes both the letter and the positive negative sign, you have to do a dihybrid cross. So there's an example that we have in our packet that talks this. And there's some background information that if you forget how to do this one, it kind of gives you a little more hints. So it talks about the RH, there's that rhesus monkey, it's the RH positive, and they've assigned the allele dominant, and then the RH negative factor, which is the absence of the antigen, is recessive. So if it talks about what would the offspring be for an expected RH positive AB woman? So we would build the genotype. I usually do the A, or the lettering system first, so that would be AB, and based on their alleles that they say, there is a, sorry, I actually got ahead of myself because now I knew this was coming. But because you have a positive blood type, that means you have the dominant allele. And they say in parentheses here, the father was Rh negative. And because that father means that he only had 2 recessive alleles, that means that his offspring must have inherited one of them. And if it's not seen in this allele, it has to be seen in the second allele. So that's how I kind of knew to build that. In the second one, it says the man is heterozygous A positive blood. So I have to interpret the fact that not only is the heterozygous going to travel to the A letter, but because positive, once again, is the dominant allele, without any background on their offspring or their parents, that would then mean this word is going to travel not just to this, but it is going to have to travel to both for this to make sense. So you have a dihybrid. And I did teach, originally if you still want to do that, you can put these genes in parentheses so you can start the FOIL method. And I'll take this parent to the left. So that means I'm going to take the first of both. So it gets a little chaotic just because of all the different letters that I'm doing here. Then we have the outside ones, not a repeat, so I have to put it down. The insides, and then the last ones in both combinations. So there you have, there is no repeated gametes, so I have to include them all. And over here, I take the firsts. I'll take the last ones, the outside ones, the inside ones, and now the last. So there are no repeats on either side. So this is going to be a true dihybrid cross. We have every square that needs to be filled in. I'm not going to spend the time doing all that. You can kind of start thinking about what it would look like. But you'll just continue. I don't know what the outcome is. I just kind of want to set that up so you realize this is how you would do a full letter, positive, negative, Punnett square. You can do one or the other as monohybrids, but when it's giving you both informations at the same time, then you want to kind of put them in a dihybrid because they want to know, well, what is the chance of getting A positive? So we have one square that has that. I don't know how many else will be in that, so you'd have to continue this problem to figure that out. But there's how you do the second aspect of blood typing, which is the positive negative.